In 6.15, Application to Engineering Practices with the Use of Cost-Benefit Analysis (CBA). CBA is an engineering decision-making procedure in number 1. Define problems. Number 2. Choose the objective. Number 3. Identify the alternative. And lastly, evaluate the impact and consequence of the alternative taken. Multiple Criteria Decision Making (MCDM) or Multiple Criteria Decision Analysis is a subdiscipline of operation research that explicitly evaluates multiple conflicting criteria in decision making, both in daily life and in settings such as business, government, and medicine. Conflicting criteria are typical in evaluating options. Cost or price is usually one of the main criteria, and some measure of quality is typically another criterion, easily in conflict with the cost. In purchasing a car, cost, comfort, safety, and fuel economy may be some of the main criteria we consider. It is unusual that the cheapest car is the most comfortable and the safest one. In portfolio management, managers are interested in getting high returns while simultaneously reducing risks. However, the stocks that have the potential of bringing high returns typically carry high risk of losing money. In a service industry, customer satisfaction and the cost of providing service are fundamental conflicting criteria. In their daily life, people usually weigh multiple criteria implicitly and may be comfortable with the consequences of such decisions that are made based on only intuitions. On the other hand, when stakes are high, it is important to properly structure the problem and explicitly evaluate multiple criteria. In making the decisions of whether to build a nuclear power plant or not, and where to build it, there are not only very complex issues involving multiple criteria, but there are also multiple parties who are deeply affected by the consequences. Structuring complex problems well and considering multiple criteria explicitly leads to more informed and better decisions. There have been important advances in this field since the start of the modern multiple criteria decision making disciplines in the early 1960s. A variety of approaches and methods, many implemented by specialized decision-making software, have been developed for their applications in an array of disciplines, ranging from politics and business to the environment and energy. In topology, there are different classifications of MCDM problems and methods. A major distinction between MCDM problems is based on whether the solutions are explicitly or implicitly defined. Firstly, multiple criteria evaluations problems. These problems consist of a finite number of alternatives explicitly known in the beginning of solutions process. Each alternative is represented by its performance in multiple criteria. The problem may be defined as finding the best alternative for decisions maker DM or finding a set of good alternatives. One may also be interested in sorting or classifying alternatives. Sorting refers to placing alternatives in a set of preference ordered classes, such as assigning credit rating to countries, and classifying refers to assigning alternatives to non-ordered sets, such as diagnosing patients based on their symptoms. Some of the MCDM methods in this category have been studied in a comparative manner in book of Gerontophilia on this subject. Next, multiple criteria decisions problems or multiple objective mathematical programming problems. In these problems, the alternatives are not explicitly known, and alternative solutions can be found by solving a mathematical model. The number of alternatives is either infinite, countable or not, or finite by typically exponentially large in the number of variables, ranging over finite domains. Whether it is an evaluation problem or a design problem, reference information of DMs is required in order to differentiate between solutions. The solution methods for MCDM problems are commonly classified based on the timing of preference information obtained from the DM. There are methods that require the DM's preference information at the start of the process, transforming the problem into essentially a single criterion problem. These methods are said to operate by prior articulations of preferences, methods based on estimating a value function or using the concept of outranking relations. Analytical hierarchy process and some decision rule-based methods try to solve multiple criteria evaluation problems utilizing prior articulation of preferences. Similarly, there are methods developed to solve multiple criteria design problem using a prior articulations or preference by constructing a value functions. Perhaps the most well-known of this method is goal programming. Once the value function is constructed, the resulting single objective mathematical program is solved to obtain a preferred solution.